Hello students of class 9, this is your general mathematics chapter 9, areas of parallelograms and triangles. Okay, this is your new chapter, chapter 9, areas of parallelograms and triangles. So in here we will start from you see theorem 9.1. okay, we will start from theorem 9.1. Now in here you listen very carefully because these are very important. Theorem 9.1 states that parallelograms on the same base and between the same parallels are equal in area. Okay, parallelograms on the same base and between the same parallels are equal in area. So in this figure you see there are two parallelograms. One is parallelogram ABCD and the other parallelogram is EFCD. These two parallelograms ABCD, look at the figure very carefully. There are two parallelograms in this figure. One is ABCD, okay, and the another one is EFCD. Understand? Now these two parallelograms are between the same base. That is, these two parallelograms shares the same base, that is DC. ABCD, EFCD. These two parallelograms have the same base and these two parallelograms are between the same parallels. That means in here AF is parallel to DC and these two parallelograms are on the same base and between the same parallels. AF and DC. Understand? So when theorem 9.1 saying that when parallelograms on the same base and between the same parallels are equal in area, in here two parallelograms are there that are on the same base DC and between the same parallels. Okay, then both of their areas will be equal. That is our theorem 9.1 it is saying. Now in here I will have to prove it. So theorem 9.1 I will prove it. This one I have already done. So theorem 9.1, parallelograms on the same base and between the same parallels are equal in area. This is your diagram. Okay. Now in here you see, first of all, I will write given parallelograms ABCD and EFCD are on the same base DC and between the same parallels AF and DC. Okay, this is our given here. I have to prove that area. This is means writing style. Okay, area AR ABCD is equals to AR EFCD. This is writing style. This means area of this parallelogram ABCD equals to area of this parallelogram EFCD. This is I have to prove it. So now I will start the proof. In here you see parallelograms, we know that opposite sides of a parallelogram are parallel. Yes, opposite sides of a parallelogram are parallel. Now if I take this parallelogram ABCD, in here AB will be parallel to BC. Okay, AD will be parallel to BC. And if I consider AF as the transversal, then this angle will be equals to this angle. Understand? AD is parallel to BC, AF is the transversal, so this angle will be is equals to this angle. Corresponding angles. Next I can take ED is parallel to FC in the parallelogram EFCD. ED is parallel to FC, again AF is the transversal, then this angle will be is equals to this angle, again corresponding angles. Now you see, if I consider these two triangles ADE and BCF, in these two triangles I have showed that this angle is equals to this angle and this angle is equals to this angle. Now in earlier classes I have already said that in two triangles, if two angles are equal, then the third corresponding angle also becomes equal, and that is our we get by the angle sum property of triangles. Understand? So in here you see, in triangle ADE and triangle BCF, these two triangles I am taking, okay, ADE and BCF. So first of all, I have said that this angle DAE is equals to angle CBF. Angle DAE is equals to angle CBF. Corresponding angles, since AD is parallel to BC and AF is the transversal. Okay. Next, again I have said that this angle is equals to this angle. Yes, this angle is equals to this angle. Angle DEA is equals to angle CFB. This is again same only corresponding angle, since ED is parallel to FC and AF is the transversal. Now in these two triangles, two angles are equal. Yes, two corresponding angles are equal, therefore the third corresponding angle, it will be also equal. So therefore I will say that this angle is equals to this angle. Angle ADE is equals to angle BCF. First that I have said that this angle is equals to this angle, that one I will take it as equation 1, and this angle equals to this angle, this is I will take it as equation 2. And then I will say that AD is equals to BC, because in a parallelogram opposite sides are parallel also and they are equal also. So therefore in parallelogram ABCD, AD is equals to BC, I can say. Understand? Now in here you see, in these two triangles, okay, in these two triangles, first of all I said that this angle is equals to this angle, then I said that this angle is equals to this angle, and then I said that this side is equals to this side. So therefore now I can say that these two triangles are congruent by angle side angle congruency. Finished? Now since these two triangles are congruent, so therefore their areas also will become equal. So therefore I can say that area of ADE is equals to area of BCF. And then last thing I will do is that with this triangle area I will add this portion area, that is EDCB. This portion area I will add it to this triangle area also, and I will add it to this triangle area also. So this triangle area plus this whole this triangle area plus this EDCB, okay, this much area, you see, I will get ABCD. I will get the area of parallelogram ABCD. And with this triangle, if I add this area, then I will get is equals to, I will get area of EDCF. Understand? That is only our last proof. I have showed that this one I have showed that this parallelogram ABCD, okay, area of this parallelogram ABCD is equals to area of this parallelogram EFCD. That is our proof. Okay, notes I will send it to you. You look at the notes very carefully. Understand? Match it with the diagram. You look the video and then match it with the diagram. In here there is nothing there. First of all I will show that this triangle is congruent to this triangle. Since this triangle is congruent to this triangle, then their area will be also equal, and both the left hand side and the right hand side I will add this portion area, that is EBCD. This portion area I will add it to both left hand side and right hand side. This one, you see what I have done here. These two triangles are congruent by ASA rule, so therefore area of these two triangles will also be equal. Now both side, both left hand side and right hand side, I will add area EBCD, I will add it. So area of ADE plus area of EBCD, I will get area of ABCD is equals to area of BCF plus area of EBCD, I will get area EFCD. This is our proved. That much only in here, nothing there. Now in here you see next example 1, figure 9.13. ABCD is a parallelogram and EFCD is a rectangle. Also AL is perpendicular to DC. Prove that area of ABCD is equals to area of EFCD. And next one is area of ABCD is equals to DC into AL. This is your figure given. So in this figure you see ABCD is a parallelogram. ABCD parallelogram, EFCD rectangle. Yes, ABCD parallelogram, EFCD rectangle, and AL perpendicular to DC given. Okay, I have to prove that the area of this parallelogram ABCD is equals to area of this rectangle. Understand that one I have to prove. So this is very easy there. First of all, you see I will write what is given. Given that ABCD is a parallelogram and EFCD is a rectangle and AL is perpendicular to DC given. To prove that area of ABCD is equals to area of EFCD and area of ABCD is equals to DC into AL. Finished? Now I will start the proof. Okay, the first one I am proving. Now you see we know that a rectangle is also a parallelogram. Yes, a rectangle is also a parallelogram. So therefore area of ABCD, that is the area of the parallelogram, will be equals to area of EFCD, that is area of the rectangle. Why? Because from the theorem that we have earlier proved, from that theorem we know that parallelograms on the same base and between the same parallels are equal in area. Yes, this rectangle and this parallelogram, okay, this rectangle is also a parallelogram. Yes or no? A rectangle is also a parallelogram. So therefore this rectangle I can consider it as a parallelogram and ABCD is a parallelogram. So these two parallelograms are on the same base DC and between the same parallels. Yes, same base DC and between the same parallels. Understand? So therefore the area of this parallelogram ABCD will be equals to area of this rectangle EFCD. Understand? So in as a rectangle is also a parallelogram, so therefore area of ABCD will be equals to area of EFCD. This is parallelograms on the same base and between the same parallels are equal in area. Finished? This is our first one. First one, it is proved. Next one. So next one you see this one you see area of rectangle EFCD. Area of rectangle EFCD, it is length into breadth. I know it is length into breadth. So therefore area of EFCD, I can write it as DC into FC. Okay, area of rectangle EFCD, it is equals to DC into CF or FC, whatever you say. Finished? Now area of, I have already proved that area of this rectangle is equals to area of this parallelogram. So instead of writing next one, instead of writing area of rectangle EFCD, I can write it area of ABCD is equals to DC into CF. Since area of ABCD is equals to area of EFCD, this is we have already proved here. And this one I will give equation 1. Now AL is perpendicular to DC. This is our given. Okay, AL is perpendicular to DC. This is our given. AL is perpendicular to DC. So therefore I can consider that AFCL or ALCF, this one ALCF, this is also a rectangle I can consider, because this is 90 degree, this will be 90 degree, because EFCD is a rectangle, so this will be 90 degree, this will be 90 degree. Understand? This will be 90 degree. Okay, so therefore in here EFCD, okay, and this one you say EB parallel to DC, and your AL is the transversal, so therefore this angle plus this angle is equals to 90 degree. From there this angle I will get 90 degree. So in this you see ALCF, in this quadrilateral, this angle, this angle, this angle, they are all 90 degree. Yes, they are all 90 degrees. So therefore I can consider that ALCF, okay, ALCF is a rectangle. Understand? ALCF is a rectangle. Understand? So since ALCF is a rectangle, so therefore AL is equals to FC, I can say. Understand? AL is equals to FC. Okay, AL is equals to FC. This is equation 2. So from equation 1 and equation 2, equation 1 is this one. Area of ABCD is equals to DC into CF, and in here, from here I got that this is AL is equals to FC. FC or CF, same thing only. So therefore area of ABCD is equals to, I can write it as DC into, instead of writing FC I can write AL. So DC into AL, this is our proved. Understand? Very easy there. First one, how I have proved? First one, I have said that EFCD is a rectangle. Okay, since a rectangle is also a parallelogram and ABCD is a parallelogram, so these two parallelograms are on the same base and between the same parallels. Yes, and between the same parallels. Therefore, the area of the rectangle, or you can say area of the parallelogram ABCD is equals to area of this rectangle EFCD. Finish. This is first one proof. Now to prove the next one, what I will say, I will consider this rectangle area of EFCD, it is equals to length into breadth, so DC into CF or FC, whatever you say. Finished? Okay, now next, instead of writing area of EFCD, I can say area of ABCD, because area of EFCD is equals to area of ABCD. I have already proved. So area of ABCD is equals to what I got? Is equals to DC into FC I got. That is equation 1 I will take. Understand? Next you see, since AL is perpendicular to DC, yes, AL is perpendicular to DC, so therefore I can say that this one ALCF is a rectangle. Finished? Because you see EFCD is a rectangle, so therefore this angle will be 90 degree, this angle will be 90 degree. Yes, and this is, we know EB is parallel to DC and AL is the transversal, so this angle plus this angle is equals to 180 degree, because we know sum of the interior angles on the same side of the transversal is 180 degree. Yes, so therefore from there this angle will be 90 degree, so this angle, this angle, this angle, this angle, they are all 90 degree. So therefore I can consider it as ALCF to be a rectangle. So since ALCF is a rectangle, so therefore this side is equals to this side I can take. Understand? And that will, I will give equation number 2. So from 1 and 2 I can say that area of ABCD is equals to DC into AL. Finished. That one only I have to do. Understand? Next it is our example 2. Okay, example 2 also, it is very important there. Example 2. If a triangle and a parallelogram are on the same base and between the same parallels, then prove that the area of the triangle is half the area of the parallelogram. Very important theorem. This is actually a theorem, but they have given example. Okay, so therefore you see, this is a triangle. PAB is a triangle. Yes, PAB is a triangle and ABCD is a parallelogram. These two triangles and parallelogram have the same base and they are again between the same parallels. So in here saying that the area of this triangle will be is equals to half the area of this parallelogram ABCD. Understand? Area of this triangle PAB is equals to half the area of ABCD. That one I have to prove here. So first of all, I will write given that triangle PAB and parallelogram ABCD are on the same base AB and between the same parallels PC and AB. Finished. PC and AB. I have to prove that area of PAB is equals to half area of ABCD. That one I have to prove. Area of PAB is equals to half area of ABCD. So in here I will do a construction. Construction is that this QB parallel to PA. Okay. QB parallel to PA is drawn. QB parallel to PA is drawn such that PABQ is a parallelogram. Okay. Understand? QB parallel to PA is drawn such that PABQ is a parallelogram. Finished. On the same base base AB and between the same parallels AB and PQ. Finished. Okay, QB parallel to PA is drawn such that PABQ is a parallelogram. Okay, PABQ is a parallelogram on the same base AB and between the same parallels AB and PQ. Finished. Now I will start the proof. So first of all, in here you see ABCD. Okay, area of ABCD will be is equals to area of this parallelogram PBQP. There are two parallelograms here. One, this one. Look very carefully. ABCD is a parallelogram, ABCD parallelogram, and the another parallelogram is PABQ. There are two parallelograms. So these two parallelograms area will be equal. From that theorem, parallelograms on the same base and between the same parallels are equal in area. And that I will give equation number 1. Understand? Now you see triangle PAB. Triangle PAB will be congruent to triangle BQP. These two triangles. PAB will be congruent to BQP. Okay, these two triangles will be congruent. Why? Because diagonal, this is PB is the diagonal divides the parallelogram into two congruent triangles. Yes, this diagonal divides this parallelogram PABQ into two congruent triangles. Finished. So since these two triangles are congruent, so therefore area of PAB will be is equals to area of BQP. Finished. These two triangles. Okay, look very carefully. Understand? Because areas of two congruent triangles are equal, and that will be our equation number 2. Now in here I can say that area of PAB is equals to half the area of ABQP. Area of this triangle will be is equals to half area of ABQP. Finished? Understand? Area of, I can say that area of PAB will be is equals to half the area of PABQ. Why? Because you see PABQ is a parallelogram. Yes or no? PABQ is a parallelogram, and this triangle area is equals to this triangle area. Understand? Since these two triangle areas are equal, so therefore area of triangle PABQ, I can write this triangle is half the area of this parallelogram. Understand? This triangle is congruent to this triangle. These two triangles are congruent. Yes or no? And these two triangles are congruent, so therefore their areas will be equal. Understand? And this is PABQ is a parallelogram. Understand? And these two triangles, this diagonal separates the this diagonal divides the parallelogram into two equal parts. Yes or no? Into two equal congruent triangles. This diagonal divides the parallelogram into two congruent triangles. So therefore, since these two triangles are congruent, so therefore their areas will be equal. Since their areas are equal, so therefore I can write that area of PAB is half the area of this whole parallelogram PABQ. Understand? Okay. And again I can say that area of PAB, okay, area of PAB is equals to half. Instead of writing PABQ, I can write ABCD, because these two parallelograms are on the same base and between the same parallels, so therefore their areas are equal. Understand? And that will be our proof. That much only, again nothing there. I hope you have understood. Understand? I can say that area of PAB is equals to half the area of this parallelogram PABQ, and area of PABQ is equals to area of ABCD. Understand? Since parallelograms on the same base and between the same parallels are equal in area. Finished? So first of all, I got that area of PAB is equals to half the area of this parallelogram. This is PABQ. Okay, and next I will write that area of PAB is equals to half. Instead of writing PABQ, I will say ABCD. Understand? That much only our proved. Okay. In the next video, I will go to exercise 9.2. I hope you have understood. Thank you.